Hi, everyone. We're going to discuss supertypes and subtypes and also business rules today. That is section 4 of your database design section. Now, both of these topics, it's a little strange for them to show up in a database class because they are things that are normally associated with other areas. Um, Supertypes and subtypes are typically really more associated with programming, object-oriented programming. So if you are one of the students who's taken some programming and you've really dug into object-oriented programming, inheritance, and things like that, this should be very straightforward to you because it's the same idea. And then business rules, typically that comes a little more out of a business analyst type of role. So that's really something that business majors might see a little more of than our INF or computer science majors. So let's take a look. When we talk about subtypes and supertypes, we'll start with that. We have a couple of things that we would be looking at. There are what we call ISA relationships, and then there's also HASA relationships. And it's basically going to be a way, and I'll share my screen here. It's going to be a way for us to determine the relationship here. What this is eventually going to get to for us is going to be determining how the database tables are set up. So this is why this is important here. So I've got a couple of examples here. We could say that cat animal, and that would be an example of what we call an ISA relationship. And in this case, if we were to kind of summarize this, so really cat is a subtype of an animal. It's like a category of animals. So if you imagine you take all the animals, you line them up, how do you sort them? How do you kind of segment them into different groups? This would be a good way to do it. Like, okay, let's put the cats over here. They probably wouldn't listen, but put them over there, put the dogs here, put the elephants here. That would be a way that you could kind of set that up. So you have a cat and it is a, or is it really be is an, but they call it an ISA relationship. Now we also have a has a, or in this case, it's not a because there are more. A library has books. Now in this case, this would be really considered a super type because what it's going to do is it's going to be containing these books. So in this case, it's kind of the opposite. The library is composed of pieces of media, the books, and all the other stuff that you might find in there. Now, a couple of other examples here. If you want to think in your head before I answer, pause. Go ahead. We have cars, and in this case, maybe you've paused. I don't know. We say car has. Here's another has an, but the car has an engine. So in this case, if we are looking at a vehicle, if we were looking to break it down into parts for maybe we're running a chop shop or something, maybe we're going to break it down and sell the pieces. The engine is going to be a subtype of that, as would the rear view mirror, as would the headlights, as would the tires, and so on. So in this case, we could say it one of two ways. You could say, in this case, the way we're describing car, engine would be a subtype. It would be a category of parts. Or we can also flip it around and say it the other way. A car is a super type of that engine. So the engine is a more specific part of that. Likewise, with departments, we could say department has an employee or has employees. And you could certainly have multiple employees in the department. And again, what this is going to do is eventually we're going to have to make decisions with a database. So just to show you a little bit into the future, eventually we might have, let's say we have a veterinarian database. I think I've mentioned that in a previous example. We might have a vets database. We might have a column saying what type of, you know, animal is this. We might want to make that a drop down: cat, dog, bird, other. Or we can also decide to put that information into another table. And there are advantages and disadvantages to doing it each way. So that's kind of the idea of supertypes and subtypes. So effectively, if we were to say soda, Coke, Pepsi would be subtypes of soda. And likewise, if you flip it around, what is the supertype of Coca-Cola? Well, what's next up the line? It would be um, soda. And then what's next up the line there, if we're modeling this, maybe beverages, canned beverages, and so on and so forth. So, but the idea we're looking for here is to think about that idea of how do we fit things into categories, because eventually that's going to become important for our modeling. Now, our second thing that we're going to discuss for two is business rules. Now, business rules are going to be very important, but I will point out that if you are going into an existing database project, a lot of times you're not going to be the one setting up the business rules. It's going to be really adapting to them, using them. There are what we call structural rules. For example, we said before a department has employees. That is a structure. Maybe a department could exist without employees. And then there are procedural. So, for example, you're in this class and you're able to register because you have completed the prerequisites, X before Y. So let's take a look at some business rules that we might find in our college environment, because that's going to help inform our database design. So let's say so this course is listed as CIS 217, or I'm sorry, INF 217 or CIS 278. So you have some sort of thing like this where you have prerequisites. This, of course, as we said before, would be an example of a procedural business rule. You kind of set up, this is the way that you this is what you must do in order to register for the course. But we also have other things that might be business rules. So um, let's say, for example, we have a new faculty member. New faculty member must be assigned to a department. If you remember, we talked about relationships. This kind of feeds into how you might shape those relationships and how you know which ones are optional and mandatory based on our business rules and interviewing our customer. And again, this is oftentimes more of a business analyst, somebody doing the requirements, and then it's up to the developers to implement. So let's say this is not the case, by the way. In my career, I've taught, like at Passaic, I taught both college success and CIS related courses, computer related courses. So I taught in multiple departments. I even almost taught physics in a pinch at some point. I did do a physics minor in college. But we could say that you must be assigned to a department. You may not be assigned to multiple departments. You could see this kind of, if we talked about one-to-one, one-to-many relationships, this can help us decide what type of relationship something is. And you can see that's a little more structural, how things are set up. So if I were to say, let's say we were talking about a student. So let's say we bring you in. You've applied for the college. You said, I'd like to be a student here. They might say that you are assigned a role of an applicant. At that point, some of the business rules that really don't concern us in the database, but might concern other programmers, might be things like students might receive an acceptance email, or they might receive a letter, through the regular old mail, but they receive some sort of communication. And let's say that student now is going to register. They're going to be moved from the applicant role to another type of role. And these type of business rules, again, if you're a programmer, you can set the database up to follow these rules. And you can imagine, if you're here, you've probably taken some programming and if statement. Okay, I can see the if statement, if X, then Y. Um, you know, so this maybe doesn't apply as much to database design, this specific one, but in terms of business rules and programming, this is certainly useful. Um, they will be moved from the applicant role to um, a, a current role or something like that. But there are also things that are a little less, less granular. You might say, a student is assigned to an advisor, faculty advisor, let's say, based on your major. If you were to change your major from something in computers to chemistry, um, what would we expect happens? Something like that might happen as well. So these are some examples of how you might see business rules. Again, some of them, like this right here or this right here, some of them may be a little more useful with our design phase. Some of them may be a little more useful with our implementation phase when we're actually creating the database and setting up our rules. Um, the other thing I will point out is that at this point, you can also say, um, student must select an ethnicity, will be one of the following, and race and so on, gender, all of these things. And you would typically want those listed out, like, okay, I might have my idea of what an ethnicity is. What does it look like in your database if you're the customer, or if somebody's doing this on paper? What is legal and valid in your system? So it's also something where you might want to go and ask. You have to ask these types of questions, and you know, must be one of that list right there. Um, you know, even stuff like might have a state in the following list, and list. So they have to have if they have a state, it must be one of those, or if they're an international student, they don't have to fill out a state, let's say. And this again sets up our business rules allow us to prevent bad data from being put in the system. So something like this, a business rule like this, would make sure that somebody doesn't enter an XX for a state. And that would be something, for example, we would call that a constraint. We'll talk about that at some point. So 4.1 and 4.2, a little less material than some of the other things there, but hopefully this was helpful for you. And I will Um, See you for next video.